Okay, so now we are looking at the question called classy numbers. This is based on digit DP. Um, so if you guys don't know what digit DP is, you can first see some lectures on digit DP. Otherwise, I'll try to explain it briefly, and then we'll move ahead with this question. This question is rated 1900 on Codeforces, so it's a pretty decent question. And once you have understood the basic concepts of digit DP, this is not a very tough question, to be honest. Like, it is not worth 1900 rating. Let us look at the question. So it says, let's call some positive integer classy if its decimal representation contains no more than 3 non-zero digits. For examples, number 4, 2, 2 lakh and 10203 are classy because we can see that this contains 1, 1 and 3 non-zero digits, and rest of these numbers contains more than 3 non-zero digits. So that's why these numbers are not classy. We are given a segment L to R. We need to count the number of classy integers x such that it lies between these two numbers, including these two numbers, right? So this is a pretty standard digit DP questions. Let me just brief you with what kind of questions are asked and are solved using the concept of digit DP. So mostly you will be given a segment L to R, and you will be given a property, right? Any property, and you will have to find total number total number of numbers in this segment such that they satisfy this particular property, right? So all of the numbers that lie in this segment, we need to find the total numbers which will satisfy this property, or we may be asked to find the sum of those numbers, and these sort of questions are basically asked using this digit DP. Okay, so now first let's see what can be the brute force solution for this. So yeah, it's very easy, right? So we have the L, then we have R, and we need to iterate all to all of the numbers, and right from L, L plus 1, L plus 2 till R, and then for each of these numbers we'll check whether the number of, like, we'll first, let's say this number is 1020 something, and then we'll count how many numbers, how many digits are non-zero in this particular number, and for every number that will satisfy this property we'll do answer plus plus, and then finally we'll return answer. And it is very obvious that this is not the optimal approach, because we can see that the constraints are till 10 raised to the power 18, and if this is the optimal approach, then it doesn't make sense that this question is 1900 rated. Okay, so so now we'll see how are we going to approach. So in digit DP, what we do, rather than moving from L to R, we see that how many digits are in these numbers. Let's say this has 8 digits, okay, and this has 6 digits. Then so basically the maximum number will have 8 digits, right? 1 2 3 4 5 6 7 8. So rather than moving from L to R, we'll move from one digit to the next digit, okay, and then we'll try to somehow like, we'll look at this property and we'll try to somehow figure it out using these digits and not the entire list of numbers, right? So so if you haven't seen this pattern, you can basically try to memorize this pattern. So we have three important states in this DP. One is index or position, basically. So we are moving from one digit to the other digit, index or position. Second is any variable that is related to the property. So what is the property that we need to satisfy? That the number of non-zero digits should be maximum 3. So we can write number of non-zero digits, right? And then the third property is tight. Let me explain you what this is. And this is the third state for all of the digit DP problems. So for every position, we may have tight as true or false, right? So let's see what this is. So let's say we have a digit 1 2, let's say 4 2 3 6 7. Okay, and we need to move from 0 to this digit. So as I said that we will not move like 0 1 2 3 and then finally to this digit. We'll write 5 digits, right? This is 5, and then we'll move ahead from here to here, and we'll make numbers that lie between 0 to this. Okay, so this can have 0, right? So if this has 0, then this can have any number, right? 9 2 3 9. It doesn't matter because ultimately this number will be less than this maximum number. Okay, if it has 1, then also we can have 9 9 9 2, right? It doesn't matter this because this entire number is less than this number. But what if we have the starting digit as 4? Then we cannot have 9 here, right? Because 4 9 and whatever the rest of the number is, this will be greater than this. So for these two condition, tight is false because uh, we have numbers which are lesser than this, so we can have any number. So we don't have a tight bound situation that we cannot use any number here, right? But here, as we have the maximum possible number, we have a tight situation here, right? We cannot have 9, we can have only 0 1 and 2. These three numbers are possible because as we go 4 3 and whatever the rest three digits are, it will be greater than this number. So this is what tight is. So I know I'm going pretty fast here because I don't really want to dive deep into digit DP. I am just briefing here. Maybe this will be good for your revision. So before solving this problem, if you are still confused what these states are, I would recommend you to first see some lectures on digit DP and then come back to this problem. Okay, so let's move ahead. What were the states that we talked about? It was position, it was number of non-zero digits, and tight. Okay, so these three will make the DP states for this problem. So DP of pos, NNZ, and tight, what will this signify? This will signify that how many numbers satisfy the property till position equals to pos, and when non-zero numbers are this much and the tight is this much, right? For example, dp of 1 1 and 1. This shows that uh, if this number is already filled, we are at this position, okay, right? So this is the first position, right? And we already have non-zero numbers as 1, so at this position we already have 1, and tight situation is also there, so we cannot use any number. We will use a number uh, from 0 to original number at this position. Okay, and yeah, this will be the situation. So from here to the rest, how many numbers are there that will satisfy the condition, right? And if somehow we are able to calculate this, right, then we'll be able to calculate this. So can you see the recursive pattern here? If somehow we are able to calculate this, then we'll be able to calculate this too, right? How? Let's say we have this, and now what we want, we are at the 0th position, right? And uh, we, let's say we have tight, and let's say let's say we have non-zero number as 1, so we have selected the non-zero number 1, and we have reached the tight situation. Then we can move ahead and take this number and add it to this, and it will get us the entire answer, right? So what will be the answer? Answer will be 0 1 1, right? So either we have selected a non-zero or we have not selected a non-zero. If this is still not clear, I'm sure this will be clear once we write the code. So we'll move ahead like this. One, we'll write first the recursive code, then we'll write the memoization code. Okay, and this is like both of these are almost the same. I may discuss I'll, on a high level I'll discuss how to write the tabulation, but it doesn't really, so it's not optimized, right? It's not optimized. This is the most optimized approach. So we can stop here basically. Okay. uh, yeah, so let's try to write the code. um, okay, so now first we'll try to write uh, the recursive code. Okay, let's see what the question asks. It asks that we are given uh, two integers L and R in the input, and then we need to output our answer. Okay, so we'll have L comma R. Okay, and so how do we approach these problems? So as I said that we'll move digit by digit, right? So it will be easier for us if we convert these L and R number to a string, so that we can move from 0 to the last number, right? I think this makes sense. So what we'll do, we'll convert these numbers. Okay, so we'll have string left. Okay, and we have an inbuilt function in string in C++ to convert integer to string. This is toString, so we'll have R, and then we'll this is str right, and then we'll have str left equals to toString. So we'll not have L here, we'll have L minus 1. Let me tell you why. So basically what we do here, we count the answer from 0 to the rightmost element, and then we'll count from 0 to the left, the one minus the left element minus 1. Why? Because then finally we'll have some answer for left, and we'll have some answer for right, and then we can basically write answer of right minus answer of left as our answer. So what I'm trying to do here is, let me just explain you. So we have to find numbers containing maximum 3 non-zero digits. Okay, so we'll first calculate from 0 to right element, and then from 0 to left minus 1 element, and once we subtract both of these numbers, we'll have the answers for L to R. This is what we are trying to do. Why we are doing this? Why not just directly move from here to here? Because see, it will be difficult. So we have a tight, right, that tells us that whether it is 0 or 1, which means whether we have the independence to select the uh, select any number or not. But if we will start from here, then we'll have so we'll have restrictions for the smaller numbers too, right? So now we'll not be able to select 0 or something or 1. It must be greater than this. Now this will become very complex, right? But from 0 to r it is simple. We'll just see whether the number is getting larger than r or not. We don't really need to care about the smaller numbers, right? And then we can directly subtract these two. And this is why what we do, this is why we calculate the answer for right, then answer for left, and then this will be our final answer. And for left we'll be selecting the number l minus 1, right? So till now what we have done, we have selected a number r, and then we have selected a number l minus 1. We'll do operations and we'll find our answers. What do I mean by answer? Answer is the total number of digits having the total number of numbers having maximum 3 non-zero digits. We'll calculate from 0 to r and from 0 to l minus 1, and then we will subtract both of these numbers, and then we'll get our answer. Okay, let's move ahead. So we need to find these numbers. So we have to make a function that will return us the long, right? So let's call this function as helper function. Okay, what it will take? It will take a string number, right? And we have to implement this function such that we get this answers, right? So answer L will be equals to helper strl, and answer R will be equals to helper strr. Okay, and then we'll subtract these numbers and we'll get our answer. Okay, so now what we'll do here, so let's recall what were the states that we were talking about. We'll start from the first position. Okay, so now if you are still confused about what my approach was, maybe I was fast or whatever, let's think about that approach while coding and it will be much more clear. We'll start from the first index. Okay, we'll start from the first index. Where is the yeah, so we'll start from the first index. uh, mm, yeah, here is our board. So let's say these are the digits. All right, these are the digits, indexes or position, whatever. We'll start from here. Okay, so what are the possible digits that can come here? Let's say we have a number for the final number as 43 4297. Okay, so we can have a number 0 1 2 3 and 4 here. Okay, 5 we cannot have, obviously. Okay, 5 we cannot have, and we don't have the freedom to select any number here, so which means the type for the first position will be true, right? We cannot choose 9 here. All right, we cannot choose 9 here, so the type for the first index will be true. So if for these three numbers, we can select these three numbers, right? For 0, our number of non-zero count will not increase, but for these three numbers it will increase. All right, if we select any of these three numbers, the number of non-zero count, this will increase. Okay, and this is very clear, right? Oh, sorry, for all of these four numbers, not just these three numbers, right? But for these three numbers, when we'll go ahead for the next indexes, the type will be false, because if we select any of these three numbers on the first index, 0 1 2 or 3, now we can select any number, 9 9 8 7, and any number. These numbers will be less than the final number. We need to find the total numbers between 0 to the final number. So the number on which we are calculating our answer should not be greater than the final number. But if it is starting from these three or four values, it can never be greater than the final number. So That is why if we are starting from these three values, the tight for the rest of the elements will be false. But if we are starting for 4, then for the next position, the tight will be fixed, because we cannot have any number. We cannot write 4 8 and start our number, because this will get greater than this number. So we can only have 0, 1 or 2 here, and 3, right? And for 0, 1 and 2, the tight for the next numbers will be false again, because if we write 4 0 and something something, 4 1 something something, all of this will be less than this. But for 4 3, we have again tight as true. And if the number that we are selecting is 0, then the non-zero count will not increase, and otherwise it will increase. I think now this should be very very clear. I have spent enough time on this. Now I believe we can start writing our code. All right, let's start writing our code. So we have some helper function, and we need to write a recursive function, right? We need to write a recursive function which will give us our answer. Recursive function, okay? And this will contain string, or we can directly use recursive function here only. All right, so what are the dp states? It is position. Okay, so now like first we are writing the recursive code, and then we'll use memoization here. Position, and then we have bool tight, and then we have non-zero numbers. Okay, see, if non-zero numbers at any point exceeds 3, can we return 0? If non-zero number has already exceeded 3, this means that there are 0 answers here, right? If we reach a position where the non-zero numbers have already exceeded a total value of 3, then we have already violated the property, right? It doesn't matter now. We have 0 answers. But what will be the base case where it is possible? So we have to first reach the end of the number, and we have to make sure that non-zero numbers are less than or equal to 3. So if we are at the line 8, which, like if we have already crossed this situation, we know that the non-zero numbers are less than or equal to 3. But if we are at a position equals to num dot size minus 1, so if we are at the final position and we have non-zero number less than 3, oh sorry, for the final position will also do the operations. But if we have completed the entire number and the non-zero numbers are greater than 3, or are less than equals to 3, which means that this number is possible, right? We have added one number, so as we have completed the entire number and the non-zero digits are less than equals to 3, which means we have one more number which satisfies the properties, right? So okay, and now for the current digit we have to simulate the our, we have to check if the property is true or not, right? So what we'll do at the current position. Okay, so we are at the current position. We have already checked whether the entire number is completed or not. Okay, so now first we'll see what all numbers can we put at this particular position. So let's do this. Let's create a limit which will be the maximum number that we can put. The minimum is obviously 0, and the maximum number is, this will depend upon whether the type is true or not. So if tight is true, then we will only be able to uh, the maximum number that we'll be able to put is uh, is a number that is there at the position index in the original number, and otherwise this will be 9. Does this make sense? Does this line make sense, or should I explain it once more? So what I have written is this is what I have written. Okay, What does this mean is, at a particular position, we are at a particular position, right? So if the tight is true, which means we cannot select any number, right? Let's say this was a number and this has 5, 7, 9, 8. So let's say previous number was 4, which means the type is true. So we cannot write 6 or 7 or 8 here. So what is the maximum limit that we can write? It is 5. So string, like this string of 5 character minus 0. This will give us the integer 5. This is a very basic thing, right? And otherwise, if let's say this previous numbers were 3, then we can have 0 to 9 any number here. That is why the limit, if type is true, is num position minus 0, otherwise it is 9. I think this should be clear now, right? What we'll do now, we'll put all of the numbers from 0 to the limit here. Okay, so for int d equals to 0, d is less than equals to limit, d is the number that we are going to push, the we're going to put. Okay, for all of these numbers we have to do something. What we'll have to do, we have to calculate that for all of these numbers what will be the answer for the rest of the string, right? For the rest of the numbers. So now we, at this point, now we have selected d for the current position, right? Now we'll move at the next position, and let's say for this state we have the answer equals to 0 currently. Now we have selected this d, some d we have selected. Now we have to count the total, we have to calculate the answer for this particular d. If we have if we have selected this d at this position, then what will be the answer for the rest of the number, right? So again we'll call helper. Let's pass it by reference for to avoid the memory issues. Help will pass number, and then we'll pass position plus 1. And tight, what will be the tight? We need to find tight, right? So okay, so let's see, we have something like called new tight for the next number. Let's figure out what will be the new tight, right? So if we are already at a stage where we have tight, right? So if we have tight for this particular position, then we'll have to check whether the current d is equal to the last digit or not, right? See, what I'm trying to say is, let's say we are at a tight position here at this fifth, like this third position, the tight is true. Then for the next position, the tight will only be true if we are putting 5 at the third place. If we are putting 4, then we can choose any number in the rest of the numbers, right? So let's write this down in the code. So new tight will be, see, if this is tight, then we'll have to check whether d is equals to limit. If this is not tight, right, then this will be false. New tight will be false. If this is tight, then we will check. So if then we'll check that the current d is equals to limit or not. So this can be written like this. So bool new tight. If this is complex, so if tight is true for this current position, then what we'll check, if d is equals to limit, then new tight will be equals to true, else new tight equals to false. And here, if the current situation is not tight, then the situation for the next number will also be not tight. Then we'll pass the tight. Okay, and now we'll see the new number of z, a non-zero, right? And then z means number of non-zero. So new number of non-zero. So if d is equals to 0, then non-zero will be equal to the previous number that was selected, and right, the non-zero number will not be increased. Else uh, NNZ will be non-zero, previous non-zero plus 1. So current number is also that we are selected is non-zero. So the next number will be having one more non-zero element, right? So now we can pass NNZ here and we can return the answer. Okay, position 0, tight for the first index will be 1. So I've already told why, and number of non-zero is 0, right? We can copy paste it, right? Let's see if this works. There's some problem. R was not declared. Why was R not declared? Okay. R L nums dot size, and the light, this is num. I think I have written nums everywhere, right? Num. Okay. Num. Num. Yeah. So now this is passed. Let's try to submit this code. If we submit this code, obviously we'll be getting some error. I solved this question on December 20, which is like 6 months back. This will get time limit exceeded, obviously. Now let's try to do the DP. Okay, let's do this. So we'll create a DP vector LL. So we have 3 states, all right. Vector, 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 LL. DP, DP1. And what will be the total number of the maximum number of position that can be there? It will be the size of this string. All right, let's give it str r dot length, and let's give +2 3 for no reason, just to avoid segmentation errors. Vector, vector, ll, and then we'll have positions. No, the second is tight. The second is tight, so this will have 2, which is 0 or 1, and the third is vector ll nz, which can be maximum 3. Let's give it 4 here, and let's pass the dp1 here, and let's pass it here too, dp. Okay, and let's initialize all of these number with -1, I guess. Okay, so if dp of pos tight and nz is not equals to -1, then return this very number. Otherwise, do your thing and return first. Populate this DP with the answer and then return it. Okay. And similarly, we'll create a DP2 here. DP2 for the next, and we'll pass it DP2 here. And here also we should pass DP. I think this should be fine. Let's try to run this. Passed. And yeah, let's try to submit this code now. Mhm. Should be submitted. So this is accepted, as you can see. Yeah, so I think this should be clear. Now let's talk about tabulation just for a minute. See, for tabulation, we'll create this DP, right? This 3D DP, and we'll start with 0th position, and then we'll first, so there will be three for loops, obviously, right? First for loop will be from 0 to position, then it will be for tight, and then it will be for the non-zero, number of non-zeros and all those things. For like uh, for the 0th position, first we'll go with tight is false, right? And then we'll move from non-zero 0 to 3, right? Up now, see that for the first position, let's move towards the board. See, for the first position, see, for position 0 to n, right, we'll grow from non-zero from 0 to 3. For tight 0 to 1, right? And then all of the conditions will be same. Non-zero is if greater than 3, then we can continue, and otherwise, right, we can move from d 0 to limit, right? We'll calculate limit according to the previous logic that we had. If tight is 1, then this, otherwise it is this. See, for 0, now we are going from 0 to 3. If we are at position 0, how can non-zero number can be, like, how can non-zero number be 1, right? It doesn't make greater than 1. Like, non-zero number cannot be 2, it cannot be 3, so it doesn't make sense, right? This is unnecessary computations which is not there in memoization, right? That is why this is not an optimized solution, right? This is not an optimized solution. The memoization is the winner here. This solution will also be accepted. I've tried sometime, but yeah, this is not the most optimized solution. The memoization for the win in this question. And yeah, this was it for this video. Thanks. We can wrap this up.